So now let us add different circuits, and then yeah. So let me just circuits AC circuits. So first, let us write AC circuit with resistor. So we have this supply from AC generator, right?
Mm.
This supply, and then we connect a resistor to it. So this is some resistance, and the current is flowing. Now we know that this voltage would be equal to, what is the voltage in the resistance?
IR.
I right. So, and we know that what is this V? This V is V naught sine omega t. Right. So this is V naught sine omega t
Mm.
equals to IR. So we can calculate I equal to V naught sine omega t divided by R. So I would be V naught by R and sine omega t. Right.
Mm.
Write this thing as I naught. So this is I equal to I naught sine omega t. So do you see any phase difference between them? V is V naught sine omega t. So will there be any phase difference? Because you see the angle is same.
Yeah.
So there would be no phase difference, right? If I plot the graph, if I
Yes.
plot the graph, so let's say this is, and you see that the I naught is V naught by R. So it would be less than,
Mm.
it would be less than V naught. So let's say that this is 90, 180. Let me draw the graph. Yes. So this is V naught. This is minus V naught. And then this is I naught minus. So we have, this is 90. This is 180, 270, and then this is 360. So this is at 0, this would be 0, right? And
Yes.
at 90, this would be V naught. And at 180, this would be 0. And again at 270, this would be
Minus.
minus V naught. And then 0, right? So this
Yes,
is
sir.
yeah, this is V naught sine omega t. Now this amplitude is decreased, right? V naught by R. So then this would be something like this. But you see what is happening, that they are in the same phase. So if it is increasing, this is also increasing. If it is decreasing, this is also decreasing. If this is decreasing, and if it starts increasing, it also starts increasing. So they have same phase. V
Yes.
and I are in same phase. Right. And yeah, so if I draw the phasor diagram, so let's say that this is what V naught sine omega t. So this is the amplitude V naught, right? This is top is V naught, and if I drop, so this is V naught, right? And
Yes, sir.
this angle is omega t. So what would be this part?
I not.
No, no, V naught, and then this, you know, the resolution of vectors, right? So
Oh,
the angle is, this is the angle, so this would be cos part, and this would be sine, right?
fine.
So this is not sine omega t, right?
Mm.
Similarly, what would be I naught? So I naught would be same, but with a smaller amplitude. This is I naught, and this would be I naught as sine omega t. So these are all the attributes of the resistive circuit, right? They are in the same phase, and I naught is omega naught V naught by R, and yeah. So this is with the resistor circuit. Please note it down.
Okay, sir.
Whenever you have noted, please tell.
Okay, sir. Done, sir.
Done. Okay, now let us. So now let us write. Let us. So the next circuit is capacitive circuit. So AC circuit with a capacitor. So what do we have? Again, we have this supply, and then we have this capacitor. So this is V naught sine omega t, and this is C with a capacitance, right? So again, what do we have? V equals to, what is the capacitance?
Uh, Q is equal to CV. What?
Yeah, so this would be Q by C, right?
Mm. Yes.
So what do we have? We have this V is V naught sine omega t equals to Q by C. So Q is V naught C and sine omega t, right?
Mm.
You see that we want to calculate the current. So how do we calculate the current from charge?
Uh, D change in charge by change in time.
So we differentiate it, right?
Well, yeah.
So with differentiating with time t. So this would be dq by dt, and this is v naught. Let me write d by dt of v naught c sine omega t. So this thing is I, and v naught c is taken outside, and we have d by dt of sine omega t. So this would be how much? This would be v naught c and
Cos
omega t, and then chain rule.
d omega.
Okay. So this is v naught omega c and cos omega t. Now we want to write it in terms of, so we know that current is V naught or V by resistance, right? So
Yes.
term, this term we can write it as V naught by 1 by omega c, right?
Hmm.
And then we can write it as what? We can write it as cos omega t. So this thing I can write it as v naught by xc, right? Where xc xc is the capacitive reactance, right? So in capacitor, the capacitive reactance acts like a resistance, right?
Hmm.
And then cos omega t, I can write it as, because I have to write it, the supply is in terms of sine, right?
Hmm.
So I have to write it in terms of sine. So I can write it as sine omega t plus pi by 2. Is it clear?
Yes, sir.
So this is the final result. So what is happening? Current is, so we have a capacitive reactance Xc, which is 1 by omega c, right?
Hmm.
Second is current is leading or lagging.
Current. I feel like it'll lead.
Yeah. So you see that this is plus 90. So
Yeah.
it, right. So
Hmm.
current is leading by pi by 2, right? So these are the things that we have. So if we draw the diagram, right? If we draw, so first let us write. This is v naught sine omega t, and then this is I naught cos omega t, right?
Hmm.
So we what do we have? This is oh, this is theta. So this is 0 degree, 90 degree, 180, 270, and then 360. So this is 0 and this is V naught. This is 0 minus V naught, 0. But you see that this is cos omega t. So at 0, this is how much?
Uh, I not.
I Absolutely correct. At 90, 0. At 180, minus I naught. And at 270, again 0. At 360, again I naught. Right.
Yes.
So this is V naught. This is minus V naught. This is minus I naught. This is I naught. And 90, this is 180, 270, and then 360. So first let us draw V naught. So this goes as like this. And then we have this I naught. So at 0, it's I naught. So it will start from here, right? Choose another color. So it will start from here. And then at 90, it goes to 0. And then at 180, it goes to minus I naught. And then at 270, again 0. And then at 360, it goes to. So my graph is not that good because it should be like this, but because of these axis is right, I have this wrong graph. But yeah, this would be the shape of the graph, right? Is it
Okay.
yeah, because if we plot it in a proper graph, then this would be correct. But I have these spaces, they are non-uniform, right? So
Yeah,
that's
I can
why
see.
shaping like this. Okay, and if we draw the phasor diagram, right? If we draw the phasor diagram, so you see that this is V naught, right? And current, this is omega t, and omega t plus 90. So plus 90 would be here, right? This is plus 90. So this whole angle is
Hmm.
omega plus 90. So this is I naught, right? Now, this and this thing is how much? So this thing is omega naught and sine omega t. And this thing is omega I naught cos omega t, right? So these are the things that you have. Okay, is
Okay,
it
sir. Yes.
okay? Please note it down. So the most important thing that we got that you have a capacitive reactance, right? And the current is leading by pi by 2. So these are the things that we have to remember. Okay,
Okay,
note
okay,
it
sir.
down.
So can you please scroll down?
Yeah, sure, sure.
Done, sir.
Done. Okay, so the next circuit is inductor. Oh, hmm. Next circuit is AC circuit with inductor, right? So we have an inductor and then it is connected to the AC supply. So this is V naught sine omega t and this is the inductance L, right? Because this has inductor has what kind of thing? Self-inductance, right?
Hmm.
So V is what? For inductor, what is voltage?
It was inductor into change in current.
Yes, yes, absolutely correct. So EMF induced was minus L di by dt, but this was only for the magnitude would be L di by dt, right?
Hmm.
So now you see that this is V naught sine omega t, and then this is L di by dt. But what is the aim? The aim is to calculate the current, right?
Hmm.
So, so di would be V naught by L and sine omega t and dt, right? So we will, in the previous case, what did we do? We differentiated because this was
Hmm.
charged, so we differentiated to get current. Now we have this integration, right? So we will integrate on both the sides. So what do we have? If we integrate this thing, di, and then integration of V naught by L sine omega t dt. So this integration is I, V naught by L is outside, and then integration of sine omega t. What is that?
Cos omega t by omega.
Minus cos, right?
Yeah, second.
And then
Oh.
divided by omega, right?
Yes, sir.
So we can write it as V naught by omega L and so this is minus cos omega t. So you see that this omega V naught by something resistance, right? So I can write it as V naught by XL, where XL is the inductive reactance.
Hmm.
So, and then minus of cos omega t. But again, you see, and I will write it as I naught and then minus cos omega t. So you see, this is minus cos function. So it would be inverted, right? But I have to write it in terms of sine. So I can write it as I naught and then sine and omega t minus pi by 2. So sine omega t minus pi by 2, this is theta, sine theta. And if I come in this direction, so this is omega t minus pi by 2, right? Or theta minus pi by 2. So it will come in fourth quadrant. And in fourth quadrant, sine angle is what? What would be sine angle in fourth quadrant?
will be positive.
No, no. So in first quadrant, all positive. Second
Yeah.
quadrant is
Oh yeah,
positive.
negative. Yeah,
Sec, and then this is tan,
will
and
be negative.
yeah. So this is tan and cos, and this is cos and sec. Okay. So in the fourth quadrant, sign is negative. So you'll get minus cos omega t, right? So sign. So this would be the answer. Clear?
Yes,
So
sir.
what we have, yeah, let me erase this part. So first thing is that we have inductive reactance, which is omega L, and also we have what? We have current is lagging by 90 degree by pi by 2, right? So what is yeah, and if we draw the graphs, so this is I naught minus I naught minus V naught and V. So we know that what is the graph of this is 90, this is 270 and 360. So this V naught graph would be 0 to 90. So this goes like this, and then this, and yeah, I got disconnected. I got disconnected.
Yes, sir.
Yeah, so okay, so what is sign in again? What is mm, yeah. So let us write the values. So this is function is this is theta, this is minus cos omega t or I naught. So at 0, this would be how much? Hmm. At 0, what would be this value?
Uh, we have to do the minus, sorry, 1.
Yeah,
So,
minus I naught. Yes, yes.
mm,
You are
no,
correct.
initially I thought maybe you have to like do minus pi by 2 and then.
No, 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 no. So we will draw the graph from
Hmm.
this, right? Because from here it is easier, right?
Okay.
Here it is easier. So you just
Mm.
draw the graph by just remembering this thing. This is to just compare it with the voltage, that whether it is leading or lagging. But we'll draw the graph from here. In the previous case also, you see that I wrote I naught cos omega t. Because
Yes.
from here it is easy to draw the graph, right? From here it is easy to draw the graph. Okay. So this is minus I naught and then 0 and then I naught and